Calorimetric calculations involving water. In this video, we're going to learn how to calculate the energy change when water changes temperature, changes phases, or both. First thing you need to understand is what happens when you heat water. As you add heat energy to water, the temperature is going to increase. If it is below 0 degrees Celsius, water will be a solid or ice. And as the ice warms, it's going to remain as a solid until it gets to the melting point, which at 1 atmosphere is going to be 0 degrees Celsius. It will then melt at a constant temperature, and when it is melted, the liquid water then can raise up to 100 degrees Celsius, again at 1 atmosphere pressure, and then it will vaporize or boil at 100, again no temperature change, and then it will become a gas. So note, we have regions of no temperature change, and those are also regions of phase change, and we have regions of temperature change, but no phase change. Here remains a solid, even though the temperature is increasing. Here it remains a liquid, either though the temperature is either increasing or decreasing. Here it remains a gas, again, even if the temperature is increasing or decreasing. And the importance of this in terms of calculations is you will use a different equation where the temperature is constant and where the temperatures change. So if there's no phase change or there is a change in temperature, that means when it is a solid, a liquid, or a gas, no phase change, then we want to use this equation. Heat energy equals the mass in grams times the specific heat, which is 1 calorie per gram times degrees Celsius using calories, or 4.18 joules per gram times degrees Celsius using joules, times the change in temperature. For phase changes, where you have constant temperature, you're going to use the equation heat energy equals the heat of whatever phase change is taking place times the mass of water. And of course, the phase changes are either melting or freezing, vaporization or condensation. The value of the heat of solidification or heat of fusion is 80 calories per gram or 108.3 kilojoules per gram. And the heat of condensation or vaporization is 540 calories per gram or 847 kilojoules per gram. We may also use other values for those particular things. But when given a problem, the first thing you need to figure out is what kind of change is taking place. So this question asks how much heat energy in calories is needed to melt 800 grams of ice at 0 degrees Celsius. So we want to melt the ice at 0 degrees Celsius, no change in temperature. So we have to use the equation heat energy equals the mass times the heat of fusion. That is the phase change that is taking place here, melting, which is heat of fusion. And so Q is going to equal the mass of the water, which is going to be the 800.0 grams. And the heat of fusion of water is 80.0 calories per gram. So grams and grams will cancel, giving you calories. And this works out to be 6.40 times 10 to the 4th calories. So again, if there's no phase change, it's just the mass times the heat of whatever phase change is taking place. This problem, we're asked how much heat is released in calories when 150 grams of steam are condensed into water at 100 degrees Celsius. So we're starting with steam at 100 degrees Celsius. We're ending up with water at 100 degrees Celsius. So no change in temperature. We only have a phase change from the gas to the liquid at 100 degrees Celsius. So again, Q is going to equal the mass times the heat of the phase change. In this case, it's going to be the heat of condensation. Since there's no change in temperature, we don't want to have a change in temperature in the equation. So here, Q is going to equal the mass, the 150.0 grams, and the heat of condensation for water is 540.0 calories per gram. Multiplying the two together, we get 8.10 times 10 to the fourth calories. So again, no phase change, or phase change only, no change in temperature. It's just the mass times the heat of whatever phase change is taking place. This question is asking how much heat energy in kilojoules is needed to raise the temperature of 75 grams of water from 18 degrees Celsius to 78. So we're starting at about 18 degrees Celsius, going to 78 degrees Celsius. Here we have a change in temperature, but no phase change. So now we want to use the equation Q equals the mass times specific heat times change in temperature. So if there is a change in temperature, you want to use the equation that has the change in temperature. And plugging in the numbers, we have 75.0 grams. And we're asked to do this in kilojoules, so we're going to use the specific heat in joules. There's 4.18 joules for every gram times degrees Celsius. The change in temperature going from 18 to 78, that's going to be a difference of 60.0 degrees Celsius. Grams will cancel with grams, degrees Celsius will cancel with degrees Celsius. That'll give us our answer in joules. This comes out to 18,800 joules. Again, we're asked for kilojoules, so we'll convert this to kilojoules by dividing by 1,000. So it equals 18.8 kilojoules of energy. But again, now we have no phase change, but a change in temperature. So that is the appropriate equation to use. This question asks how much energy is needed to change 25 grams of water at 20 degrees Celsius. So we're starting with water at 20 degrees Celsius, and we want to change this to steam at 100 degrees Celsius. So now we have to raise the temperature up to 100. And so for that change, we have to use Q equals the mass times specific heat times change in temperature, since there is a change in temperature. Once you get to 100, it's going to remain constant at 100. We have to vaporize it. So there we have to use the other equation, Q equals the mass times the heat of vaporization. And then we'll have to add the two together. So for the first part, the mass is 25.0 grams. We want to do this in kilojoules, so we're going to use 4.18 joules per gram times degrees Celsius. And then we have to go from 20 degrees up to 100 degrees where it's going to boil. And so that is going to be a value of 80.0 degrees Celsius. And all that is going to come out to 8,360 joules, which will equal 8.36 kilojoules. That gets us from the 20 degrees to 100. Now we have to vaporize it. So there, the heat energy is going to equal the 25.0 grams of the water. And the value of heat of vaporization in kilojoules is 2.26 kilojoules per gram. Multiplying those together, we get 56.5 kilojoules. And to get the final answer, it's going to be the amount of heat needed to raise the temperature up to 100, plus the heat needed to vaporize it. And that'll come out to 64.9 kilojoules. So again, always handy to think of this heating cooling curve, try to imagine what change is taking place, then use the appropriate equations. Last example, how much heat energy is needed to raise the temperature of 500 grams of ice at 0 degrees? We're starting with ice at 0 degrees, and we want to get to water at 85 degrees. So we have to melt the ice, then raise the temperature up to 85 degrees. And so for the first part, to melt the ice, heat is going to equal the mass times the heat of fusion. And then for the second part, the heat is going to equal the mass times specific heat times change in temperature, since it'll all be in the liquid state and there will be a change in temperature from 0 up to the 85 degrees. So first calculation, mass of the water is 500.0 grams, and the heat of fusion of ice, or the heat of fusion to melt water, is 334 joules per gram, and that comes out to 167,000 joules, or 167 kilojoules, since we want to answer in kilojoules. Second calculation, the mass is still the 500.0 grams, although now it's water and not ice since we've melted it. And we're going to use the 4.18 joules per gram times degrees Celsius. And we want to go from 0 degrees up to 85 degrees. So the temperature change is 85.0 degrees Celsius. And all that is going to come out to 177,650 joules. Converting that to kilojoules and rounding to the same number of sig figs that we're going to have to add together, that's going to come out to 178 kilojoules. Final answer then is going to be the 167 kilojoules plus the 178 kilojoules, which comes out to 345 kilojoules. So again, pay attention to the heating cooling curve. Use the appropriate equation. When it's only a phase change, it's Q equals the mass times the heat of whatever phase change is taking place. When you have a change in temperature, Q then is going to equal the mass times specific heat times change in temperature.